This is a lesson for 16-1. What you're doing today are three different types of regressions. You're doing linear regressions, quadratic regressions, and exponential regressions. We have done some of this stuff before, so some of it will sound very familiar. So remember what the different functions look like, all right? This is a very, very important thing. It is a multiple choice type question a lot of the times. They'll give you a graph and say, what type of function is it, all right? So remember that a linear function forms a straight line, all right? A linear function forms a straight line. A quadratic function forms a parabola. It might be a U shape like this. It might be an upside down U shape, but a quadratic function looks like this. Remember that a quadratic function always has the x squared term in it, all right? That's sort of your clue that it is a quadratic function. And then you have an exponential function, a times b to the x power. That to the x power is sort of your clue that it's an exponential function. Remember, exponential has the x in it, and the equation like that has to the x power in it. That's how you can remember it. And it just forms a single curve, whether it goes up or whether it goes down. So those are what your three functions look like. So remember that the first thing that we need to do when we're doing regressions is you have to make sure that your stat diagnostics is turned on. So remember, you have to go to your mode button. All right, you have to go to your mode button, go all the way down to that fourth to last one, which is your stat diagnostics. If your stat diagnostics are not turned on, you won't be able to get the right answers. So remember, you have to go all the way down here, tab over, hit enter. And now that black background should jump over to the on. You have to have your stat diagnostics on. Remember, if you reset your calculator for whatever reason, doing second plus 712, remember, it will automatically turn the stat diagnostics off. So you always have to make sure that your stat diagnostics are on. Otherwise, it won't give you like those R values and things like that. So remember that the way that we're going to do this is you're going to be given a table. You're going to have to go to stat edit and type in your values into your L1 and your L2. Remember that your X values go into your L1, your Y values go into your L2. The other thing that we need to keep in mind is how to do your calculations. Stat and calc. After we have our numbers from our table typed into our L1 and L2, we need to go to stat. You need to tab over to the right to access calc. So stat, calc. And then number 4 is the linear regression. 5 is for your quadratic regression. And 0, which you don't see on the screen, you have to arrow down all the way to the 0. All right, that for the exponential regression. All right, so those are the 3 that we are using. So stat calc 4, stat calc 5, and stat calc 0. When you look at your R values, remember that your R value equals 1 indicates a strong positive correlation. An R value of -1 indicates a strong negative correlation. It's strong when it's close to 1 or -1. Positive because it's a positive number, negative because it's a negative number. So the closer that they get to 1 or -1, that's where it's strongest. To make a prediction of a future value for the X, you can sub the value into the equation and solve, or many times you could go to second and table and get it from the table as well. If you're asked to find the Y, you have to set a second equation equal to that value for Y, graph Y equals that number, and then find the intersection point. We'll have one like that on the notes today. So we're just going to do one of each. So take a look at this first one. This first one is a linear regression, all right? Linear regression for this first one. The table shows the number of miles traveled for work each year for 6 years. Predict the number of miles that they'll travel in 2014. First of all, you have to think back to when we originally learned this. Remember that anytime that we have years, years start with 0. So are you going to type in 2006 into your stat edit? No, you're not going to type in 2006. Years start with 0. So 2006 is year 0. 2007 is 1. 2008 is 2, 3, 4, and 5. We are not typing in those years. However, if it was months or days or anything else, then it will. All right, then whatever number you're given, that's the number that you'll use. So let's type these numbers into the L1 and L2. So we have 0, 1, 2, 3, 4, and 5. In our L2, the miles traveled, 8,300, 7,750, or 7,550, 8,005, 7,600, 6,935, and 6,405. So always make sure that you double check your data, because if you even have one number typed in wrong, it will throw off everything else. All right. So first thing that we want to do is let's do our linear regression. So when we go to do our linear regression, we're going to go to stat calc, and then we need to do number 4, stat calc number 4, hit enter. Do we want the numbers in the L1 and L2? Yes, we do. So we can just hit enter until we keep on going down to calculate. And it gives you this information. So remember, the equation, the generic equation, is y equals ax plus b. So we have to sub in our a value in for a. We have to sub in our b value in for b. A good rule of thumb, remember, is if these are whole numbers like they all are, we're just going to round to the nearest whole number. If they were all rounded to the nearest 10th, then we'd round to the nearest 10th. All right, so we're going to have y equals negative 335, because that's our a value, x, and then our b value is a positive 8303. Since it's positive, it's going to be plus. If it was negative, then it would be minus. So it's plus 8303. So that is our equation. Our correlation coefficient, remember, that's our R value. So R equals, we're going to put it to, I don't know, let's put it to the nearest 10th, 100th, thousandth, 10,000. All right, let's go to the nearest 10,000. So negative 0.9011. We would round to the nearest 10,000. To make a prediction for 2014, first of all, we need to figure out what year that would be. All right, 2012, if we keep on going in our table, 2012 would be year 6. 2013 would be year 7. 2014 would be year 8. So this is really year 8 that we're talking about. We go to our y equals. We need to type in our equation. So negative 335 x plus 8303. So that's what we type into our y equals, whatever our equation is. And now all that we want to do is we want to get a prediction for what 8 would be. So I could just hit second and table. Go down to my 8 in my table. And I can see that 8 is 5623. Let's go back, and I probably should have done this first, but let's go graph these points. All right, if we graph these points, I'm going to skip every other one here. All right, so 0, 1, 2, 3, 4, 5. All right, we just have those 5. And let's count by 1,000s going up. And again, I'm going to skip every other one. 1,000, 2,000, 3,000, 4,000. Many, many times on the Regents exam, they'll make you do this and graph it as well. So when we take a look at graphing this, year 0 is 8,300. I'm just going to switch colors so you can see it a little bit better. 0 is 8,300, so that would be right approximately there. Year 1 is 7,550, so that would be about right there. 2 is 8,000. 3 is 76. Oops, I did it in the wrong spot. 2 is 8,000. 3 is 7,600. 4 is 6,900, so just under 7,000. And 5 is 6,400. So right about there. So those would be our dots that we would use. We don't connect the dots. We're not forming any lines. We're not doing anything like that. We just have to graph it, find the linear regression, the R value, and your prediction for 2014. Questions on this one? So that was your linear regression. Your linear regression, we're looking for the straight line. All right, we're looking for the straight line that would go sort of through that, the line of best fit there. Quadratic regression, all right, quadratic regression. So we're going to go back to stat and edit. This time we have X values and we have Y values. We're just going to type them in exactly how they are. So we have 0.1, we have 0.2, 0.3, 0.4, 0.5, 0.6, and 0.7. In the Y column, in your L2 column, we have 8. We have 8. We have 12, 14, 16, 18, 10, and 2. So again, always double check your data just to make sure that we are doing it correctly. Let's go and graph these first because that's really what I should have done on the first one. So this is 0, this is 0.1, this is 0.2, 0.3, 0.4, 0.5, 0.6, and 0.7. And then it looks like our biggest number is 18. So I'm just going to count by twos. 2, 4, 6, 8, 10, 12, 14, 16, and 18. So 0.1 is 8. So 0.1 is 8. So I'm going to put a dot right there. 0.2 is 12. 0.3 is 14. 0.4 is 16. 0.5 is 18. Right now it looks like a straight line, but then all of a sudden it starts coming back down in a hurry. So you can clearly see that U shape forming, right? Because remember, a quadratic regression is going to be a parabola or a U-shaped graph. So now that we have those points, now we need to come up with the equation. So stat calc, we want to do the quadratic regression, which is number 5. So stat calc number 5. We want to use our L1 and L2, so we could just go down to calculate. And it gives us all the information that we want. So we have y equals. Again, our y values were whole numbers, so we're just going to round to the nearest integer, round to the nearest whole number here. So we have negative 130.9. So that's going to be negative 131. Now be very careful here. Remember, the generic form has that x squared after your a value. So this is negative 131 x squared. Our b value is closest to 98 when we round. And that has an x after it. And then our c value is negative 1.7. We're going to call it minus 2. All right, negative minus. All right, so minus 2. Our r squared value is, we'll go to the nearest 10,000th again. It is 0.8958 when we round. So that would indicate another strong positive because it is very close to 1. And it's positive because it's a positive number. To make an estimate for 2.5. Again, you could take this 2.5 and sub it in, but honestly, I think it's easier to use the table, all right? Now, remember that you can change what you count by in the table, all right? You can change what you count by in the table by hitting the plus sign, all right? Notice press plus for delta table. So if I hit the plus sign, they want to know, what do you want to count by in the table? I want to count by 0.1s because that's what we are counting by here. So then I want to get all the way down to 2.5. So I'm just going to go down, all the way to 2.5 to get my prediction. So 2.5 is, that's not the number that I have on here. Oh, duh, because I forgot to type in the equation. All right. So make sure that you go back to y equals and type in the equation, because that was the equation for the previous problem. So we have to type in this equation: negative 131 x squared plus 98x minus 2. So make sure that you type that in. Don't make that same mistake that I just made. Second in table. Now it will give me the right answer. It is negative 575. Now be very careful here. All right. I don't know if you remember doing this before, but the y column here is rounding, all right, because only a certain number of digits fit there. We need to tab all the way down to 2.5 and tab over. It's really not negative 575.8. It's really negative 575.75. You have to be very careful there. Go all the way down and tab over, because that column is rounding it because there's just not enough space. So that is our quadratic regression. The last one is the exponential regression. So again, we want to go to stat and edit. Let's clear out what's here. So we have 0, 1, 2, 3, and 4. So we're going to type in 0, 1, 2, 3, and 4. For our y values, we have 15, 40, 110, 300, and 850. We could graph those right away. So 0, 1, 2, 3, and 4. I'm going to count by, I think I'll make each one of these 100 going up. So this would be 200. This would be 400. This would be 600. This would be 800 going up. So 0 is 15. So that's all the way down here at the bottom. 1 is 40, still down here at the bottom. 2 is 110. 3 is 300. And then 4 is 850. Notice how I'm getting that exponential curve on my graph. So now that I have that exponential curve, I'm going to go to stat and calc. Remember, 0 is for exponential regression. So I got to go all the way down to 0 and hit enter. I'm using my L1 and L2 so I can go down to calculate. And it gives me what I need to type in. Again, to the nearest whole number, we're going to have y equals. Notice that it is a times b to the x power. So a times b to the x power. Our a value, rounded to the nearest whole number, is 15, times our b value 2.74. 2.74 is just 3 to the x power. Our correlation coefficient is our r value, not our r squared value. It's our r value. It is 0.9999. So that would indicate a strong positive correlation. All right, strong because it's really, really, really close to 1. So now we need to make a prediction for 7 hours. make sure that you remember, not like I did on the last question, go back to y equals, and we have to type in this equation. 15 times 3, caret button. Remember, the caret button is right above the division sign on the right-hand side. And then x. And we can hit second and table. We want a prediction for 7 hours. Now, this is still in the points. I could just scroll down, but I think it's really easier to change it back to counting by whole numbers. So I'm going to go back to my 0. I'm going to hit the plus button. I don't want to count by 0.1s anymore. I want to count by ones. So 7 is 32,805. If they asked you to predict what 2,000 cells, how many hours it would be, all right, you can sort of guess right here that it's in between 4 and 5. All right, if you look at the numbers 1,200 and 3,600, it has to be in between 4 and 5. But the way that you actually could do it would be to actually type in y equals 2,000, hit graph, so that we're graphing the exponential curve like that, and we're graphing the line. Now we can't see it, so we need to zoom out a lot. And it's probably going to freeze. But you would have to then do the intersection point between those two. All right, you'd have to zoom out again. And I'm just going to tell you that it's approximately 4.45. All right. The calculator is just going to take a while to calculate that out.